Hello, my name is Vignesh Senthil Kumar, and today I'm going to be going over the second lecture in the math lecture series for the math section of the SAT. So today we're going to talk about exponents and radicals, and just as a heads up, we're going to update how we upload the videos for the math section specifically. So since there are multiple topics, like a lot of topics that are on the math section, we're going to try to publish multiple videos a week on just the math. Like the writing and reading section so far are going to stay the same. However, for the math section, we're going to publish multiple videos a week in order to try to cover all the topics before you guys take the exam. So yeah, so that's just a heads up. And these videos aren't going to be as long, hopefully, since there are going to be multiple of them. So yeah, but today we're going to talk about exponents and radicals. So these two are some of the most fundamental topics in like the SAT math section. You almost always find at least a couple of exponents or radical questions, as you guys may have already seen from when you guys took the exam. So, so these two are very important like parts of the exam, and the most important thing to know for these two sections would be to memorize the rules of exponents, which I have right here. And these are the notes, the lecture notes. These are going to be posted on Google Classroom alongside this video. So if you want to look at these notes and like actually like look at it, go on a Google Classroom, as well as hopefully there are some practice problems at the end. So hopefully you guys do those too. But for now, let's go over these rules of exponents. So the first one is the multiplication rule. A to the x power times a to the y power equals a to the x plus y power. So basically, let me give an example of what this would mean. So let's say I have 2 to the third power times 2 to the 2 squared. That would equal 2 to the fifth power. So I basically just added 2 and 3 to get 5. Division rule is similar, but instead of adding, I'm subtracting. So a to the x power divided by a to the y power equals a to the x minus y power. So an example of this, let's say I had 2 to the third power divided by 2 squared. That would give me 2 to the 1 power, which is just 2, because anything to the 1 power is just the same. I hope you guys already know that. So yeah, so here I subtracted instead of actually added like I did before. Now power of a power rule. A to the x power to the y power equals a to the x times y power. And then let's give another example of this. Let's say I had 2 to the 2 cubed, 2 to the second power. That would give me 2 to the sixth power. So yes, so in here I multiply the 2 and 3. Now we have power of a product rule. A times b to the x power equals a to the x power times b to the x power. An example here, I'm gonna use variables here because that's the easy way to explain this one. So x times y squared, that would give me x squared times y squared. Next, I have power of a fraction rule. This, oh yeah, a over b to the x power equals a to the x power over b to the x power. Both this and the previous one are basically similar to distribution. So that's how you can like remember these two rules. So here, let's say I would have 2 over 3 to the fourth power. This would equal 2 to the fourth power to 3 to the fourth power, and then you could further simplify to get your answer. Next, zero exponent. So that's basically saying anything to the zero power is just equal to 1. So even if I have like 1,000 per se to the zero power, that would just equal 1. Next, we have negative exponent. So a to the negative x power equals 1 to the a over x. That's basically trying to find the reciprocal. So let's say I had 5 to the negative 1 power, that would just equal 1 over 5. Or if it was 5 to negative 2, it would be 1 over 5 squared. Next, we have fractional exponent. This one is the most important for when dealing with radicals, because usually like some questions would ask you to convert exponent form to radicals, or radicals to exponents. So this is actually important. So here how it works is we have a to the x over y power equals a to the x to the white root of a to the x power. I may have said that a little bit like weirdly, but it's written out here, and I'll explain it to you in like an example too. So let's say I have 8 to the 3 over 2 power. That would basically mean that the answer would be the cube root of 8 squared, if that's simple. Actually, no, sorry, my bad. I messed up there myself. That would be the squared root of 8 to the cube power. So yeah, so the denominator would be whatever that root, and the numerator would be 8 to that power. So that's how you could convert exponents to radicals. Now let's do a couple of practice problems. I've linked 15 practice problems plus their answers here. I would hope that you guys do all 15 of these like right now, or like maybe pause the video, look at them, or if you go to the Google Classroom and open the notes and actually do them, because these are really good practice. So, but right now I'm just gonna explain a couple of them, like maybe like 4 to 5 of them, and then I hope you guys do all of them. And also another thing you guys should know about the math section is the only way to do good in the math section is to keep on practicing. So hopefully you guys would be going on like Khan Academy or any other like practice problems online, just such a practice SAT practice problems, and like any section like SAT exponents practice problems like that, and do practice problems online. Because like I said in the last video, the curves are gotten really bad recently, so you really have to get like as high as the score as possible because every single question matters even more nowadays. So yes, so now let's just go over a couple of these practice problems, like so that you guys get an overall view of these how I use like the laws of exponents. So first, let's start off with number one. If a to the negative 1/2 power equals 3, what is the value of a? Well, here I'm just gonna start. I see that's to the negative power, so I'm immediately gonna do the reciprocal. So I'm gonna do 1 over a to the 1/2 power equals 3. Next, I have 1/2 power, so I'm gonna make that into a radical. 1 over the square root of a equals 3. Next, it says I want to try to make the I don't want 1 over root a. I want to make it to root a, right? So that's simple for me to solve for a. So in order to do that, I'm gonna try to find the reciprocal of each one. So you can make, so the next step could just be finding the reciprocal of each one, and that you can do that when solving something outside. Now, it's not gonna be 3. It's gonna be 1 over 3. You're allowed to do that, and why you're allowed to do that is because it's basically the same as multiplying both sides by to the power of -1. So that's how you can like just find the reciprocal of both sides in order to help solve the equation. And now we're gonna square both sides, and using the same fraction square thing, I'm gonna square the top and the bottom, and that's gonna give me a equals 1 over 9, and that's the same as answer choice B. Now, the next one I want to go over is number 7. Number 7 is one of those questions where it says if a and b are positive even integers, which of the following is greatest? So this is one of those questions where you could solve it rationally by thinking it through, using the properties that you know. But the easiest way to do it is using substitution. Substitution is a method that we often use in order to try to make questions like these easier. Because since we know it's multiple choice, we can just substitute answers and just like plug in the random numbers for these two variables and solve it doing this way. So here, what I would do is it says a and b are positive even integers. So I think in my mind, what are two positive even integers or even one that I could plug in for these two variables? The easiest one that comes to mind is 2. Always go with the simplest one you can plug in. So let's just say a equals 2, b equals 2. So now let's plugging in a equal 2 and b equal 2. Let's plug it into all of these answer choices and see which one gives me the highest number. Because it's saying which is the greatest. So here, this would be -2 times 2 to the 2 power. This would just be -4 squared, which is the same as 16. Now b, this one would be -2 times 2 to the 2 times 2 power. This would equal -4 to the 2 times 4 power. And this, you can just make, since we have -4 to the 2, -4 to the 2 here, we can just make this 16. Oh, sorry. I think I may have written that wrong. Sorry. Let me just write that properly so you guys, so there's no confusion. So we can just make this into 16 to the 2 squared, because we have -4 2 here, -4 2, and we know -4 2 squared is 16. So because we don't have a calculator for section, so I don't want to do. Cause some people don't know what -4 to the 4th power is. It's 256, but we know it's greater than 16, so we know A is not the right answer. C, this would be 2 times 2 to the power of 2. This would be 4 squared, which is 16, and we already said 16 is not greater than 16 squared, so it's not, it can't be C. Next, D, 2a, 2b, 2 times a to the power of 2b. Here, this is what they're trying to trick you, and you're gonna use PEMDAS. Because remember, you first solve for exponents and then you multiply. So basically, easy way to do it is like draw like parentheses around this. So it's 2 times a to the 2b. It's not 2a to the 2b power. So this would be 2 times 2 to the 2 times 2 power, and then that would be 2 times 4. Sorry, my bad. This would be 2 times 2 to the 4th power, and that's just 2 times 16, and that is 32, which is not greater than 16 squared. So we know D is incorrect. So that way that's how we solved for 7 is B. Okay, next one I want to go over is number 11, because this is one of those radical questions. So I have the square root of x times square root of x equals x to the a power. So since I want to solve for a, I know I want to try to convert this into exponent form. And how do I convert radicals to exponent form? Using that rule of exponents that's right here. Fractional exponent rule, like this one right here. Sorry, I don't know why I crossed that. Yeah, sorry. Yeah, so using that rule, that's what we're gonna do. We're gonna use that rule to solve for number 11. So the easy way to do this is, so you usually when you have something like this, you want to start from the inwards. You want to go expand, like you want to start inwards. So first I want to start with this square root of x. So I'm gonna make that into x to the power 1/2 because I know that's how I can convert to exponents form. So now we have square root of x times x to the 1/2 equals xa, and this larger square root, remember you can make that into x to the power 1/2. So this is x times x to the power 1/2 to the power of 1/2 equals x to the power of a. Oh my god, sorry, my bad. Let me just make this simple. X to the power of a. And now we're gonna multiply this 1/2 out into both of these, like this, how we like the distributed both. This is gonna give us x to the power of 1/2 times x to the power 1/4, because 1/2 times 1/2 is 1/4, equals x to the power of a. This is, and now since I'm multiplying these two, we add the two exponents, which gives x to the power of 3/4 equals x to the power of a, and that means a is equal to 3/4, and that's answer choice B. So far, all of these have been B, so that was just a coincidence. Now the final one I'm going to go over is number 15. If x to the 8th power times y to the 7th power equals 333, and x to the 7th power times y to the 6th power equals 3, what is the value of xy? This is similar to a previous question earlier in this problem set, but this is also a good one. So how you want to approach this problem? You, this is a common thing in the SAT. If it asks for the value of if it asks for the value of x, y, that instead of just like one variable, if it asks for like an expression, that means you should be able to manipulate these two expressions in order to get this expression. So I think in my brain, how can I manipulate? What are some patterns I see with these two that I can relate to this? Well, I think back to the rules of exponents, and one of them is this one. If you divide two of these like this, you subtract the exponents. So I look back at this question and I look, 8 minus 7 is 1, 7 minus 6 is 1. So if I divide these two expressions, I should be able to get xy. So that's what I'm going to do. I'm going to do x to the 8th power, y to the 7 over x to the 7, y to the 6th equals 333 divided by 3. Just make that a little bit cleaner. Sorry, let me just make this a little bit cleaner. Equals 333 over 3. Okay, now I can subtract these things. So 8 minus 7, 1. So x, 7 minus 6, 1. Y equals 233 divided by 3. Just like for these two problems, you can use the calculator, but hopefully you guys want to do this in your brain. This would just be 111 or 111. So xy is equal to 111. That's your answer. Sorry, equals 111. So yeah, so that's basically the gist of this set of like these types of problems. So again, like I said, you just have to keep doing practice problems, hopefully find some online and do the rest of these problems. The answers are at the end. So if you guys have any other questions, leave them in the comments below, or you can message one of us, or you could post in the Google Classroom comments. So yeah, that's basically it. Hope you have a nice day, nice weekend, and I hope you guys do well on your SAT and get your dream score. Thank you.